Enots Engineering, I'm Alan. In this video we'll take a look at some of the projects we've made over 2019. If you wish to see more projects or just look at some of the ones we've already shown, go to my channel Enots Engineering by typing in Enots Engineering under the YouTube search, click on me and then playlists, and you'll find lots of videos on various subjects. I'd like to take this opportunity to thank you for your support by subscribing, making comments and just watching the videos. So a big thank you to you, and also I wish you all a prosperous and happy new year. So let's have a look what we did over the year. I removed the packing case, being careful not to catch the staples that had been used to hold the case together. The first thing I did before I fitted the machine onto the stand was fit the feet to the bottom of the stand. This part's the stand, but you can fit the machine to a table. When the machine arrived, this top part was bolted to a pallet with the table, and the base was separate. If you buy a machine like this, the first problem you'll get when it arrives is how do you lift up the 425 kilo of the milling machine onto the stand. So for a home workshop you'll need some lifting equipment. I hired a small truck that would lift the pallet, lifted the machine up, put the table underneath. From there on it was quite simple, just to put these 4 bolts in each corner to bolt the machine to the base. I've located it next to the lathe. We'll start at the top of the machine. On this machine there's a small motor which powers a rise and fall of the Z-axis. Just below and to one side is a bigger motor which powers the spindle. On this control panel we have emergency stop, power on, spindle stop, spindle forward, spindle reverse, and this controls the column so you can lift the spindle down. On the front of the machine we have a gearbox. There's a gearbox inside here with the high and low speed and 3 different settings for each. See down here it goes from 75 RPM up to 1600. There's a digital height gauge to see how far the spindle's moved up or down. On the side of the gearbox we have a lever. This is like a drilling machine where you can pull the handle and the spindle will come down for drilling. There's the original tool, and you can see I should be able to get another tool out of this. Now what I'm going to do is I'm just taking it out the chuck. I'm going to turn it around, put it in about halfway. The next job is to machine this part here down to this diameter, so I'll try holding it on the end, and I'll put a centre in this end just to support it so I can turn this down. What I'll do now is put centre in the headstock and then hold it between centres to finish off. I'll leave it at that. So now we go to the other end, change the carrier to the other end. The body's 13mm, but obviously the body you can make whatever size you like. So I'm just setting up on the milling machine. I've milled away semicircle. This is the first cut for the insert edge. The second cut will go this way to form the shape for the insert, giving the 45-degree edge. There's the pocket for the tip, which goes on there. So all that remains now is to drill and tap. After tapping the M4 hole and fitting the insert, I set the cutter up in the lathe to test the finish. Now I'll start to turn the angle. What I want to do is get so this end just shows into the end of the Morse taper, so I need to come down a bit more on the top. Just check it on the, comes into the bottom, that's okay. You'll see it's a bit on the small side, but that's ideal for what I need. What I want to do is machine 3 grooves in this wood. This is a 3mm wide cutter, so I want to go to a depth of about 4mm. But I'm not going to do that in one go. Take it a millimetre at a time. Turn it in a millimetre. Clean the groove. And come out. Bit at each end. Wipe off any excess, because you don't want any lumps of glue, because this glue I think will dry hard. When you've trimmed the edges off, this is what it's for. You can just turn it into your Morse taper, and that's cleaned the Morse taper. If you use it on this is a number 3 Morse taper. And the more you use it, this will slowly get flattened down to the same shape as a Morse taper. Now I've set that tool to the correct radius for a 17mm spherical. What I want to do is just form a spherical on this end, and then I'll decide where the centre line is. I can then move it down until I get to the position I need. That's the finished item. See, it clips in there okay, moves round. And here's the finished part, the spherical bolted onto the plastic bracket. The bolt comes out of here, and what I've done on the end is drill a hole in the end of the bolt and fitted some brass so it just fits into the gap, and this just prevents the spindle from twisting. And once you've taken that off, this shaft here with the handle on should pull out straight through, and that's what you have on the end. This is your handle for lowering the drill, and all it has is a gear that engages in the spindle, and this is where your nut goes. So once you've removed the handle, this spindle should just come out. You can see what you have on this is a bearing on the end, the quill inside with this one's a number 2 Morse taper. You can line up the holes in the side to put your drift through, and on the other end is another bearing, and this has got a circlip on that just stops the spline shaft pushing down through the bearings. So the only way you can try and stop this moving in the casting is tightening this screw up, which grips and pushes the quill over onto the casting. So I'll measure the bore size, see how oval it is. 39.85. 39.9. So that's 0.05 difference, which is 2 thou. So that's not worn that much on this. So 2 thou ovality after 20 years, not too bad. Now I need to put the spindle in. And it just goes through the bearing. And through the back bearing. So I'll just put the spindle in. Before I put the spindle in fully, I need to put the pulleys on this end. What I've done is marked up on the pulley and on the spindle where the flats are, well, where the grub screw are on the pulley and where the flats are on the spindle. So I can put this on here. Put the second nut on. Next we fit the belt tensioner. That goes on this way. It just needs a bit of play there. So all the tensioner's doing is just keeping a slight tension on, and you can see if I go backwards there is some play in that belt. It's a tough belt, so it doesn't need to be like a V belt. It doesn't need to be too tight. I can just tighten that up there. Make sure that everything turns. Okay. Then the next job is to tighten up the grub screws behind this. Turn it to the next one. Into the grub screw. You can see it's moving. Tighten it up. I've just booted the computer up, so I want to see if it will work. I'll type in a 50 degrees. See, that's working okay. I'll just show you on the computer the readouts I'm getting. So this is the axis. So if I press 0, I've zeroed it. Axis A, the angle you want to go to, say 150. Press return. And here you see it's gone to 149.9850. So if I say I want to go to 360 degrees or 0, let's put A 0. Repeats to the 0, 9850. So it's repeating to 3 decimal places. But whether that is actually doing exactly that on the rotary head, I'll have to check that. So to fit this to the milling machine, I use these cutouts, and a clamping bar can go inside the cutout to clamp it down to the table. 2 on this side, 2 on the other side. 29.5. It's 30.06. Set the cutter on centre line to the part. I just fitted the cap heads, threaded the 6mm M6 cap head on that side, so that's finished. All I need to do now is drill a hole in here 10mm. This is a 30mm bar steel that's just clamped to it, so now I can put that back in the 4-jaw chuck and just tidy up the outside. Should do it. It's just taking all the rough edges off. Let's put a chamfer on it. Okay, here's the part fitted to the pipe. This is the milling machine control box. This is the digital readout display of my lathe. This one has 2 axes. I've ordered a 3-axis one for the milling machine, and the display cases are exactly the same. As you can see, it was a rainy day in Warwickshire, but that didn't put us off. and one of the main reasons for going to the shows is to see what tooling's available. Oh well, that's it for today. Thanks for watching, hope you enjoyed that, and we'll see you next time on Enots Engineering.